Good day and welcome to Iaqradio Plus. This week is episode number 562 and we've got a great show for you. We're going to replay one of our best panels from the Healthy Building Summit 2019. This panel was the Practice to Research Restoration panel, and members of the panel were John Downey, Dr. Ralph Moon, Dr. Felicia Cianciarulo, and the Z-Man, Cliff Zlotnik. We had a great time at the summit and a fantastic group of speakers. Before we get started, though, let's thank our platinum sponsor.
Iaqradio Platinum sponsor is John Downey Products, where restoration and abatement contractors shop. Visit them at johndon.com. That's JONDON.com.
I also want to thank our gold sponsors, Particles Plus, Healthy Indoors Magazine, Gray Wolf Sensing Solutions, and AEML Inc. Laboratory. And of course, our association sponsors, CIRI, the Cleaning Industry Research Institute, the Indoor Air Quality Association, and the Restoration Industry Association. This is our esteemed restoration panel here. We're going to start with Ralph Moon, Dr. Moon, then we're going to John Downey, who I think is giving some of his time.
I will be giving some of my time to Lee Center.
Lee Center, who's the IICRC Standards
Vice Chair.
Vice Chair. Okay, very good. And then we're going to Dr. Felicia Cianciarulo. Not too bad anyway.
Close.
All right, close. And then we're going to the Z-Man, Cliff Zlotnik. So we're going to start right now with Dr. Moon.
Thanks, Joe. So the theme of my short presentation is the importance of research and science in the area of restoration and in defending various parties. My first project was with the Fabricaris Institute in, I think it was Maryland. And years ago, they asked, and I'm not sure how they got my name, but I was working with Dr. Chen Yang and another scientist on whether or not mold was removed during dry cleaning and washing. And it was a fundamental question because at the time mold was gold, and a lot of restoration contractors were recommending that clothes be dry cleaned to remove active fungal growth. And our research showed that it didn't work. The clothes looked good, but microscopically the spores were still viable, and there were still hyphae fragments that were wrapped like a grapevine around the particles of the fabric particles. We looked at petroleum ether, tetrachloroethylene, and just washing with soap and water and bleach. And of those three, the soap and water was the most effective. And that steam pressing afterwards also diminished the viability just by killing the spores. And the least effective was the petroleum ether, which had very high concentrations of viable spores afterwards. The other thing that was a little bit different, but we tested for it, was the transfer of mycotoxins. We found that if you washed clothes that were moldy, had active mold growth, that the mycotoxins were transferred from the contaminated contents to uncontaminated contents in the washing machine. So we thought that was an important finding, and also gave us an idea that if you're going to wash moldy clothes, do so in a very isolated manner because it will cross-contaminate the other materials. But I think it also gave a perspective to the restoration industry at the time that maybe it wasn't a good idea to just recommend that they be dry cleaned. I've still read some articles where people still served as they've been proponents for dry cleaning moldy clothes, but I sent them in the article and they didn't send me anything back. But nonetheless, it doesn't seem to work as well as we anticipated. After that time, I got involved with, as a consultant, representing principally insurance companies in defending cases of water damage. Although I do both sides, I'm not invited that often for plaintiff. I'm mostly invited for defense, and that's just the nature of the work. But nonetheless, we found that in the early 2000s that a lot of the opinions coming out in court were just opinions. They weren't based upon anything. And so the first thing we did is we looked at mold growth on wall assemblies. And we wondered, how fast does it grow, rates, what sequence is the growth? And we found there was a sequence of, not a succession, but a sequence of mold growth, principally with Aspergillus penicillium in the first 7 to 14 days, then Cladosporium, then Ulithrix, and other things that grew with time. Of course, that would vary depending upon the placement of the gypsum board, but the point is that we had a perspective on how things looked. And we looked at these wall assemblies over a year to see how they deteriorate, and we essentially used those in some cases. Another one was the deterioration of Carpetac strips. We recognized early in the game that when we went to a water loss, and you pull back the carpet, is the Carpetac strips are always deteriorated. We thought, well, how long does it take for it to deteriorate? So we studied Carpetac strip deterioration for 8 years to see how they changed over time and essentially turned to almost dirt. It takes about 8 or 9 years for that to happen. But it gave us a perspective when we went to go to someone's home. There's a water loss, we pull back the carpet, and if we don't see really competent Carpetac strips, we can estimate the duration within 100 days, or within the first 100 days very accurately. After that, it would go by years. But clearly, there's a huge change when Carpetac strips have been wetted multiple times and how they look physically. We moved from Carpetac strips onto cabinet damage. And I think it was at lunch, John Downey asked me, well, certainly you have some financial support by the cabinet industry for your work. Wouldn't that be nice? No. Now, all this is self-funded, and it is for another reason, and that is that if I go to court and we fund our own research, then it can't be criticized as being paid for by somebody. Because no matter the quality, if it's been peer-reviewed or not, if it's been paid for by somebody, the opposing counsel will twist that into someone's opinion that they gave you the answers. So we don't accept any money for any of our research. But the cabinet damage studies were done in a way to figure out all the combinations. Cabinet damage where water is dripped from the inside, like from a water supply or a P-trap, from the bottom up, if you had an adjacent source. And we also looked at elevated humidity, and we had another combination. But over a period of 6 years, looking at plain, vinyl, melamine phased, water with detergent, water without detergent, we have a pretty good understanding how that works. And that has helped us immensely in interpreting the rates at which physical changes occur in cabinets. From that, we went on to wood deterioration. We looked at plywood, 2 types of plywood, interior, exterior, OSB, solid planks, and particle board, faced, unfaced. And we looked at it over a period of about a year with continuous moisture and repeated moisture. And that has all been published. All these papers have been published by the National Association of Civil Engineering, Forensic Engineering Congress, which elevates its stature, that gives us a chance to go to court and support our opinions with science, which is basically our responsibility. Then we moved on to metal corrosion. And when we noticed water damages in kitchens and bathrooms, we'd open up the cabinet doors and notice that the hinges were corroded. And we wondered, how long does that take to happen? So we looked at cabinet hinges, both concealed and regular, escutcheon plates, angle stop valves, the sink counter connection, the water supply stainless steel connection. We exposed it to freshwater mist, saltwater mist, high humidity, and ambient conditions over a period of between 270 and, we had several experiments, up to 335 days. And it was remarkable. We did elemental analysis of the metal, and we found that some materials are very conducive to surface corrosion quickly, and some are not. And so we published that information too. But again, back to the basic premise, is if I go to court and if I look at some concealed hinges and they're severely rusted, I can say with some confidence, we've tested this and it takes over a year for that to express that same degree of rust, even if you spray water on it constantly. So clearly this is not a short-term loss. And finally, we also worked in the area of paint deterioration and metal corrosion, working together, looking at 10 different types of paint, different types of primers for a Department of Defense presentation on maintenance. So we are continually adding to our library. We look at the published articles as like armor plating when we go to court, and it's absolutely necessary to do that as an expert to protect yourself against about the merits. And the other problem, if you're going to serve as an expert witness, is there's something called a Daubert challenge. And some states are under Frye, some under Daubert. Frye requires for you to express your opinions based upon general acceptance by the community. It's kind of vague, but it means it's generally accepted. Daubert is more of a federal court requirement to show that you can substantiate your opinions, not only with the general community, but it's been accepted, it's been published in peer-reviewed journals and so forth. And that's a higher, much higher level. And so for the most part, when you are challenged for your opinions under Daubert, you have to establish that your opinions are based upon science and they can be supported by published articles. So that makes a big difference in why the investment in research is so important if you're in the restoration side or the consulting side to substantiate your opinions. Otherwise, they can throw the expert out or at least limit what you can testify about. So we spent a lot of time doing that, and it represents thousands of hours, which is no remuneration by the company, except they give us the chance to do it, and they provide the room. But I think there's lots of benefits in defending our clients and explaining in a truthful way what we found through our research. So that's a central theme, again, of this presentation, the role of research to substantiate our understanding of restoration. And of course, there's an infinite number of different permutations and combinations that we talked about, even at lunch, about simple things like carpet cleaning that have not been explored but could be if there's the necessary incentive and there's enough people who really want to learn to elevate the stature and the credibility of the industry through science. And that's really what the invitation's about.
Thanks, Rob.
Yep.
That was fantastic.
And speaking of the carpet cleaning company, when I heard Ralph's, I think what Ralph just said is something simple as carpet cleaning. I just want you to know, Ralph, carpet cleaning is not simple. Another comment before I get started. Joe talked about a distinguished restoration panel. Well, I have to tell you, I am not a distinguished restoration guy, unfortunately, so you're going to be disappointed. But in fact, it was funny that you brought that up because I got a call actually this morning that I took a message from an Anthony Miller with C.A. Riley Insurance. Wanted to add companies to their recommended contractor list and wanted to know if I would do it. I told him no, I will not. I am not going to be available 24/7, 365. That ain't going to happen.
But you did cover the water.
I know probably too much about it.
Okay.
Yes. And remediate, and because of this conference in particular, because of remediation, I wanted to also say a quick thing about Joe's conference. This is 4 or 5 years I've been coming here. It is by far my favorite conference to attend, but more than my own because I'm working at my own. But the quality of the presentations, the quality of all the people here contributing is huge. And I look around this room and several people here have written articles for Cleaning Science Quarterly and or the IICRC Technical Journal. So, and I will also add that both of those publications are the type of publications that Ralph is fond of because they're peer review publications, and it's a whole different ballgame than like a trade magazine article. If you're publish it, well, actually the main thing from my perspective about a peer review publication is they are really hard to edit. It takes a long time to edit them. And there's a lot of work that goes into it, but the result is really good information. Now, about what we're supposed to be talking about. As Joe said, I am the Executive Director of the Cleaning Industry Research Institute, or CIRI, and CIRI's background actually comes from the cleaning industry, from the janitorial cleaning industry. It started in 2004. My involvement goes back a couple years, and when I became involved 2 years ago, I brought a vision of a organization that would also include disaster restoration, remediation, and what I call the professional cleaning industry. Not that Jansan isn't professional, but people that clean carpet, upholstery, etc. On location in residential settings. And so I am very fortunate to be working with this organization because we are a very small organization. Several members are actually at the table with me right now. They're my customers. I have to be nice to them. What was I saying? About SERI, the Executive Committee of SERI has been extremely helpful and agreeable in doing the things that I wanted to do became what they wanted to do. And a lot of it has to do not only about research and science, but also about communicating those things within the industry, which does kind of lead us to research to practice, or more importantly, flipping that paradigm and going practice to research. As was mentioned earlier, I'm going to have Lee Center, who is, as was mentioned, the Vice Chair of Standards for the IICRC speak, because the IICRC, I think, has an important role in this discussion right now, because they're kind of looking at things in a new way again, or in a new way perhaps for the first time, in terms as it relates to their standards and as it relates to proper science, proper research in order to support quality standards. But before I get to that, sorry Lee, you'll have to wait, another quick note. Karen, who spoke this morning, kindly and with Joe's suggestion, invited me to participate in the conference at Ohio State. Go Bucks. No, never mind. I see you there.
Don't you forget.
At Ohio State, it's the first time I've ever been at an academic conference, and what was really cool about it from my perspective was I'm not a PhD, I don't even have a college degree. I have 5 kids who graduated from Ohio State, but I don't have a college degree. But all these smart people were looking to me because I was the only guy there that knew a significant amount about cleaning. Not that they didn't know anything, but it was funny to be in a group of such brilliant minds that they were actually looking to me for information. But what it did is it opened something in my mind about the importance of SERI in a different way, and that is I've come to call it a connective tissue. SERI is not a trade association. SERI is a professional technical organization. It's a research organization serving the 3 industries that I already described. But there really is, what I came to realize is there is so little communication between practitioners and contractors and the academic community. And we think there's no research out there. There's a ton of research out there. I mean, I was bombarded. It was great. But everybody had these PowerPoints with all this data on it, and I had, I think I did have a PowerPoint. It had words on it. I'm an editor. But it really was significant to me how by being in that group, I was able to learn so much about a world that I didn't know, and I would dare to say most of us in this room don't know. And what was really cool about it was I really think that there's potential, and what was really nice was that there was a desire on the part of the academics. I'm not sure everybody, but certainly a fair number of the academics there were very interested in understanding what's going on in the quote-unquote real world so that they can be more effective in their research, but both in the way that they seek out research and what projects, as well as making sure that what they do actually gets used rather than put on shelves. I think you guys would agree that a lot of times your research goes on shelves, and that's not really good. So, yeah, I had one final thing I wanted. It's kind of an announcement. This is the first public announcement of it. I have been working for the past several months with ISIAC, which is the International Society of Indoor Air Quality and Climate, on the possibility of working together on the Healthy Buildings 2021. And just as a matter of fact, late last week, I got word from their board of directors, our executive committee had previously approved it, that they had approved, doing it as a partnership between CIRI and ISIAC. And for those who aren't very familiar with ISIAC, it is a largely academic organization, and their conferences are research conferences. What we're going to do is we're going to, kind of as we're doing here, we're going to flip that to some extent so that we involve practitioners in the conference, both in terms of research that they have done, as well as panelists to discuss research projects that have been done in the academic field. So that is in June of 2021, and it is in Hawaii, in Honolulu. So
the exact dates yet, Rick? Just
June, I believe it's 8th to the 11th. June 8th to the 11th. 8 to 11, 2021.
Honolulu.
In Honolulu. And I want you all to know I'm going to have to sacrifice by going out there ahead of time a few times. I've got to do my work. And with that, I will hand it off to Felicia. Or
to Felicia
next.
This is research I'll be talking about today that regards the biochemical and microbiological analysis of pre and post cleaning of air moving fans after restoration. And so, as Joe said, I've worked very closely with Cliff, and my two students that are part of this project were Sydney Obang and Julia Fryer. And I normally say this because it's true. I don't have the pleasure of working with graduate students. So my students are undergrads. So they're still good work, but just, you know, it's a big learning curve for them. This is their capstone experience, and they've never really done research before. So causes of contamination are catastrophic flooding, water and wind damage, vandalism, fire, sewage intrusion, blood trauma, hazmat remediation, drug laboratories. There are others. Sources of added contamination, and we've been talking about this a lot today, are house dust. And this is related to the type and number of occupants. What are the housing conditions, the age of the house, and the habits of the occupants. Now, the non-living components of dust would include insect fragments, pollen, shed human and animal cells, hair and fur, soot and soil, particulate matter, pesticides, lead, allergens, and asbestos. The microbial components of dust, which means the living parts, are airborne bacteria, fungi, mold spores, insect eggs or insects themselves, and desiccated biofilm. And so here you have a couple pictures of pollen, a little dust mite there, our friend, and a mold spore. Some additional components that may be in the environment are skin, hair. This is an insect fragment. This is a starch fragment. Actinomyces spores. Of course, there's going to be other fungal spores, pollen, and other particulate matter like a wood particle. So our rationale for this experiment was centrifugal fans used in restoration projects are minimally or not cleaned or sanitized in between remediation sites. So things that may be done are air blowing the interior and wet cleaning the exterior. So our hypothesis was that if this was not done, then there is a high likelihood of cross-contamination and unnecessary exposure to workers and occupants. So, before we started, this is right here, it was a dry air technology blower that was left on a job site for 4 months. And we were swabbing, we did a swab sampling for culture prior to the test cleaning. So we had a collection of samples of air movers from sewer backup that had sat at this site, and we sampled them. The swabs were incubated at 37 degrees for 24 hours in a tryptase soy broth, which is your normal broth. It's not selective, it's not differential, they like it. It has lots of goodies in it. The broth was then plated on the same type of auger, and the results are here. So from this was one type of blower. You can see there's a multitude of colonies that were formed. So some of these were prepared for gram staining. Different types of bacteria. In this study, we focused primarily on the bacteria. So we didn't focus on the fungi. Another of the blowers, again, had quite a bit of bacteria. And the third. So, starting, we already know that there's a lot of bacteria on these blowers. Now, this is just a representative gram stain. So, many times, the bacteria that tends to accumulate on surfaces after long periods of time is a spore former, which is bacillus. And you can see here, you can see the little spores here. These are the bacillus. So these a lot of bacillus here. So the question then that comes up is, who's at risk if these blowers are not being cleaned? So we have building occupants, there's an exposure risk, restoration contractors, pollution and contamination risk, and insurance carriers or underwriting risks. So the questions that we now set out to answer based on our preliminary results: does drying equipment pick up and retain particulate matter during operation? Well, we sort of have that answered from the initial preliminary study. When particulate matter is retained, what is the likelihood of detachment? Compare equipment cleaning options and confirm the level to which the equipment can be cleaned. So the first thing we wanted to do was search for a safe dust stimulant. And we used what's called Holi Powder. So Holi is an Indian holiday. And the powder consists of cornstarch, food color, and water. And it has an aerodynamic diameter smaller than PM10. And you can see here, this is the festival right here, and they just cover themselves and everything else in it, but it's very visual. So in experiment 1, we used a new air mover, a Contair Edge. This was staged outdoors. I'll show you a picture in a minute. The student donned PPE. The new air mover was placed on a table outside, and pressurized aerosol of pink-colored Holi Powder was added to the blower. The electrical power was then added to the air mover. Well, we didn't do it yet.
No. You said that we applied the Holi Powder, we turned on the air mover.
No, you're right. So, yeah, we had the can of pressurized Holi Powder and then supplied the electrical power and had a makeshift windsock that monitored air direction. We turned on the air mover and discharged the aerosol can for 4 minutes into the intake of the running air mover. Then turned off the air mover and used compressed air and an air cleaning gun to remove as much of the pink Holi Powder as possible from the interior and the exterior of the air mover. So in the top picture, this is the student using the Holi Powder into the air mover. And you can see here, this is after the air, we used the air pressure to clean it as best as we could to simulate what might be done in the field. And you can see here that there was still quite a bit right here and over here on the blower. So the same air mover was brought indoors, and we attached a white insole bag to discharge to the discharge of the air mover. We lifted the air mover 4 to 6 inches off the ground, dropped it 3 times to simulate job-related handling. Yeah, I'm sorry. Sorry, guys. So this was telling. It was quite a bit of a surprise. So here is the beginning of when we attached the bag, and then this is after. This is a clean bag, and then this is the outside of the bag. This is this bag after we had the air mover on. And you could actually see the pink dust come through the bag, which I'll show you in a minute. On the inside of the bag, you can see how much particulate Holi Powder there was.
That was 4 seconds?
Yeah.
Mm-hmm. Yeah, the aerosol can held 4 seconds. Okay.
So maybe I'm not going to show you that was the picture actually. So it's not really that clear here, but this is white, and then this right here, it was completely pink on the outside, like a pink hue. But the inside, it's clear that a lot of that Holi Powder was dislodged. So the results from this experiment that we gathered were the compressed air and the air cleaning gun partially removed the pink Holi Powder from the interior and the exterior of the air mover. But Holi Powder was still visible on the unit, predominantly on the blower wheel. After turning on the air mover, the Holi Powder was visible on the interior, through the material, and on the exterior of the insole bag. So the conclusion at this point is dry particulate matter deposited on the interior of the air mover dislodges during subsequent operation. So experiment 2, this is what we called mover 56. It was just labeled that. It was dry air technology. It was a clean but used air mover. And again, this was staged outdoors. The student donned the PPE. The used air mover was placed on a table. Now we measured a mixture of 50% UV Holi Powder and 50% bacteria bran powder, which we refer to as UV BBP. This was placed in a B&G bulb dust arm model, hand duster, and we supplied electrical power to the air mover, used a makeshift windsock to monitor the air direction, turned on the air mover, discharged the contents of the UV BBP into the intake of the running air mover. Then turned off the air mover and did the same process, used compressed air and an air cleaning gun to remove as much of the residue from the interior of the air mover. This time we sampled the air mover for ATP and microbial analysis during the process, and then while outdoors we attached again that white insul bag to the discharge of the air mover for later. Now, same number 56, we lifted the air mover off the ground, dropped it 3 times, and after turning on the air mover, the residue wasn't visible on the exterior of the bag because the bag was white and it interfered with us seeing the UV interference. So we couldn't see that pink. We didn't use that same brand this time. Now the mover was cleaned with B&G Versafoamer. So right here, here's how we made the bran. So we had broth and we had bacillus growing in it. And then we mixed that with bran flakes. And this is using the bag, which again, because of the Holi Powder, we weren't able to get that contrast as we did before. And then this is the cleaning process, which Cliff is going to talk more about. This is actually the student adding the bran mixture to the blower. So after that initial cleaning, you can see that the UV tracer and the bacteria bran mixture was still present after the pressurized air. Whoops. So you can see it here, here, up here. And then this is on the blower wheel after the initial cleaning. So using the B&G Versafoamer, it was ineffective in efficiently removing all the visible particulate from the interior and blower wheel. So with the second part of this experiment, there was a partial immersion cleaning in a warm detergent solution method for cleaning the interior and the blower wheel. And a 20 GPM pump was used, and a small brush was used to clean the grills, and a sponge was used to clean the exterior. The water rinsed the interior, and we water rinsed the interior and the exterior with a garden hose and a spray nozzle, removed moisture with a compressed air gun, misted alcohol to displace water from the electrical connections, and removed any liquid with a compressed air gun. We then sampled the air mover for ATP and microbial analysis after cleaning. So again, Cliff is going to discuss this in more detail, but this is the process that I just described. So in the ATP measurements, we used an ATP hygiene monitor, and that measures relative light units. We sampled different areas before and after cleaning, And we also did parallel microbial sampling using sterile swabs, and then we plated those. So the microbial results. This is before. And so again, you can see there's quite a bit of growth here. So let's see, we have intake grill, blower wheel, outside grill, blower wheel. And then so when you count, they're overgrown, which means there's more than 200 colonies in the first two samples right here. And these weren't so high, the grill and the wheel, for whatever reason. But after the cleaning, you can see the numbers, especially in these two samples, really were decreased, and that's shown up in here. So that's your colony forming units.
Viable.
Yes.
It was used in the former, probably
Yeah. So then we measured the ATP levels from the inside blower wheel and the intake grill, 55 and 56. And so at first, when you compared it to what is clean, the sample failed, and then after the cleaning, it was reduced by almost tenfold. This one, again, we might there's a slight. I would think these would be higher, but I mean it didn't go up, so it still was a good result. So from the results of the before and after plates, the number of bacteria in the before plates showed that the bacteria were present. ATP levels showed the cleanliness of air movers, indicating, especially in the one sample, that the potential of the spread of contamination without proper cleaning, the potential's there. So future direction, where we are right now with this is, I have a student who's been working for, well, when she finishes, she will be been working on this for 2 years. What she has just designed is a fogger. She built her own fogger, and we're going to repeat these using either E. coli or bacillus. We haven't decided, and we're going to do 3 trials in one day, using the same bacterial stock, so we're controlling any variability, and we're going to go through the cleaning method each time and look for is it repeatable. And so we'll do colony counts, and then we're going to do ATP measurements. And from there, I mean, hopefully the goal is, to be able to get this information out to practitioners. And so Cliff is going to describe more of the process.
IAQ Radio Platinum sponsor is John Downey Products, where restoration and abatement contractors shop. Visit them at johndon.com. That's JONDON.com. Gold sponsors are Particles Plus engineers and manufacturers of feature-rich particle counters and air quality monitoring instrumentation. Learn more at particlesplus.com. Count on us. Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions available at healthyindoors.com. And AEML Laboratories, free FedEx shipping, great pricing, same-day results, and never a rush fee. Learn more at AEMLinc.com. Gray Wolf Sensing Solutions, who use advanced sensor software technology and embedded computers to provide superior environmental test instrumentation. Visit them at wolfsense.com. Association sponsors are the Indoor Air Quality Association, a multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Learn more at IAQA.org. And RIA, the Restoration Industry Association, the granddaddy of the restoration industry. Network with leaders. Learn more at restorationindustry.org.
CIRI, the Cleaning Industry Research Institute. See more deeply through science and research. Learn more at ciriscience.org. That's CIRI science.org.
Okay, just a little bit of background information. It was by absolute coincidence that someone I knew had this water damage in their basement. It was a cement basement. They had a sewer backup. The city paid for the remediation, and these air movers were placed there after the remediation and just left for 4 months. But what was great is we had 2 pairs of matching air movers. 2 were made by Dry's, the other 2 were made, by another company, and then we bought 2 new ones. So we actually had 6 air movers to work on. Personally, when we were doing restoration in our company, we started cleaning air movers in 1987. We thought it was a problem back then and began cleaning them routinely. But I don't know that many people that do it. I think within the industry, I would say the vast majority of the people don't do it, and probably the people that do it don't do it right. So I'm going to try to show you how to do it right. Okay, so all right, background. Felicia talked about dust. I'm not sure. Does anyone here have a cat? Anyone allergic to cats? Okay, now what happens if we take the same air mover from their house to your house and we have cat dander or cat allergen in it? I think this stuff happens all the time. I think there have been problems that could have been litigated, but no one really ever put two and two together. So I think there's an issue. The dust in every environment's different. The dust is influenced by that occupant's lifestyles, pets, so on and so forth. And what we found is residues do not deposit on surfaces uniformly. Plastic has an inherent electrical charge. Some plastic has a greater electrical charge than others. And some of these blowers had metal fins. Some of these blowers had plastic blowers and fins, and it seemed like we actually had more on the plastic ones than we had on the metal. What are your expectations when you rent a car? You expect it to be clean, you expect it to be, odor-free, and don't you think our customer on a restoration project is entitled, to the same thing when they rent a car? I think they're entitled to a clean and sanitized air mover. So I think this is the customer's expectation. They think it should be new. They think it should be in a box. And one of the cool things about plastic is anything wrapped in plastic looks new. And realized this in 1987 and began wrapping the air movers in a plastic bag. So it went in. We even had a little tag on there. This is clean, sanitized for your protection. We found that people did appreciate it. Okay, here is an air mover that I actually saw on a job. I don't know if you can see how dirty it is, but this was, okay. This is in a Giant Eagle supermarket, actually in the produce department. So, happened to be in there blowing around. Okay, so in terms of dry soil removal, we've refined the process a little bit, and I kind of moved away from the air compressor on the right and moved over towards I would just call it an electrical blower. It's like it's a smaller leaf blower. It's not the really big one. It's a much smaller one. And PPE is important, and I suggest, unless you have a clean room, that you could do your initial decontamination outside, or if you have a room where you have filtration, that would probably be a good idea. The first process that we tried was an engine cleaning gun, and I've had previous really good success in restoration cleaning other things with this process, electronics, wood furniture, so on and so forth. So I really thought that this process would work well in removing the particulate, and it really didn't. It did not, was unsatisfactory. So the next thing, I was doing some research on the internet, and I found a website where this fellow shows you how to build your own ultrasonic cleaner. And I thought it was kind of an interesting thing. And essentially what this involves is buying a tub, a plastic tub, and to the side of the tub, what he has done is he attached a vibrating sander, like a hand sander, and he bungeed this on. And believe it or not, it creates a lot of bubbles. You can see them. I'm not sure what the Soundwave is exactly, but they actually showed this website, and he cleans this engine from his vehicle on there. So we tried that. That didn't work well either, okay, believe it or not. So I was kind of getting frustrated. Then we tried the foamer, and this was a small little foamer from the pest control industry. And one of the interesting things about this particulate is it gets into places that are really inaccessible. Like in certain situations, you have to take the grills off the side of the air mover because the fine particulate will get underneath there. There's really no other way to get that out. So this didn't work that great either. And then I started thinking about water wheels and how they work. And you can get electricity from a water wheel. They used to, in granaries, that's how they would grind the grain, by using a water wheel. And I came up with the idea of getting a tub and putting into the tub a pump. And this whole project cost me about $2,000 because I would come up with all these ideas. I'd buy all the stuff, and then it wouldn't work, and then you have to buy more stuff. But it was kind of fun because once you get the right stuff, it worked. So this pump was the only sump pump that I could find that gave you the option of either a vertical discharge or a horizontal discharge. So we utilized the horizontal discharge, and then we placed it, so you can kind of see how it's placed. Over on the left, the tub's empty. You put the air mover in, you have your sump pump here. We would fill it up with warm water right to the bottom of the blower. We wanted the blower to be submerged, but we didn't necessarily need the motor to be submerged. And of all the things we tried, this worked the best, and this worked the fastest. And we're not sure whether it's hydraulic pressure, whether it's hydrostatic pressure, but that volume of water moving those, because it spins the fins in the water and it kind of cleans itself. And that's what we found actually worked the best. So that's a cattle trough. It's a plastic cattle trough. And we found that one worked the best. So if you're going to try to do this yourself, take your air mover to Tractor Supply or wherever you're going to get your cattle trough, and be sure that you get one that works well. One of the things that we did is we also, as part of this cleaning process, we actually lifted the air mover up and we rotated it. So I rotated it all around. I wanted that water to get all the way, to just clean the entire inside of the housing. Because again, when you know someone who has a real long Q-tip swab and you're not sure where they're going to stick it and look, and you're going to get graded on it, you want to be as sure as you can that you've removed as much residue as possible. It actually takes about 10 minutes to run an air mover through the entire cycle, from dry cleaning, through wet cleaning, through demoisturization, and dry again. And I ran it through 2 cycles of that, so I wet cleaned it twice. As far as the moisture displacement and drying, 2 ways to do that. We used isopropyl alcohol. We used isopropyl because it doesn't leave a residue. Other alcohols do have do contain chemicals that can leave a residue. Isopropyl does not. We applied it with a compressor and a spray gun. As far as wet cleaning went, you can use, what we used was, initially when we did it, we used a cleaner disinfectant. And what I found is it actually foamed a little bit too much. So I've kind of played around with it, and now I'm to the point where I'm using a low foam, just cleaner. I don't know that you need a disinfectant at all, because the alcohol is a very good disinfectant. And you know, when we displace any moisture and any connections around the motor, and we just give the whole thing a shot, and the alcohol evaporates, and we blow it off, and all is good. Those were just, you know, some added tools. We would have a brush, we'd have a sponge, etc. A couple of tips if you're going to be doing this. One of the things that I found is you don't want to be bending over when you want to do it, so you want to have a table or some sort of stand. You also want to let the you also want to let your tub hang over maybe about 6 or 8 inches over the table, and by drilling a hole and having a drain underneath, we would put like a bathtub plug that you would have in your bathtub and a cord, and you know, we could empty and drain the tank. You know, when I cleaned a blower twice, I used the same water, but I'm not sure how many blowers I can clean before I change the water. You know, we'll probably do some more experimentation with that to kind of determine it. You know, some tools for taking your grills off. This was I don't know if you can see the brush. Here is yeah, it's a long brush. That was really good for the, you know, getting in grills or getting in fins, or, you know, kind of getting into cracks and crevices, paintbrush, etc. And, you know, when we were done, you know, it goes in plastic and ready for the next project. But I think the industry really needs to do this. And again, it doesn't cost a whole lot of money to do this type of science.
Have you thought about repeating it with a air scrubber or negative air machine, anything like that?
I'm sorry?
So have you thought about repeating it using an air scrubber or negative air machine or anything like that?
I'm not sure that I understand the question.
Basically repeating the experiment instead of using an air mover, but a negative air machine.
Oh, to clean a negative air machine? No, we're probably going to go there. Probably going to go there, yeah. Yes, Larry?
So your 2 methods, one's the dry clean, the other's the wet clean?
Well, the dry clean is the pre-clean. Okay.
So, I mean, you run the air mover through 2 cleaning cycles, is that they both the wet clean?
Yes, yes. I ran it through 2 cleaning cycles, right? And I probably could get by with 1. The only reason I ran it by 2 is I knew we were going to be sampling, and it was just a matter of, you know, you don't want to go through the whole thing and be real embarrassed in the end. So.
Would it work for the rinse to just have a rinse tub in addition to your soap tub?
Do I think it would?
Just have another pump and then clear water, whatever?
Well, when we clear water rinse it, it's the same thing. So we're hitting that blower, so we can spin the blower both ways. You can, you know, shoot in around. And in all honesty, I'm really not worried about getting water on the motor. I mean, you know, some of you know, from restoration have been cleaning electronics, computers, stuff like that for a long time. So I think that technology is available. So, you know, and you know, in 1987, we kind of figured out that they could take a little bit of water, providing it dried them. So.
Did you always take the inlet ring off?
The grills, yes. I always did that because underneath the grill, you couldn't really get good access any other way, Larry. David.
Did you run them after you sprayed them with the alcohol to dry them out? You let the machine run until the next one comes to
You could, and what we did was not run it for a long period of time. I ran it just to be sure that it ran, and if there were no sparks or no smoke or whatever, right?